Hey everyone, welcome back to the channel. And if you watched my last video on loop engineering, you already know that the old way of prompting AI is changing fast. Today we're going deeper into something even more fundamental, context engineering. Here's the thing. When we talked about loops, we focused on how the AI works autonomously. But there's a question we didn't answer. What determines whether each iteration of that loop produces good output or garbage? The answer is context, not the prompt. The context. Anthropic just published a major blog post on this. Andrei Karpathy named the concept. And the entire industry is converging on one idea. The skill that matters in 2026 isn't writing better prompts, it's engineering better context. Let me show you exactly what that means and how to start doing it today. Let me start with a scenario every developer has experienced. You type, write me an authentication module into Claude or ChatGPT. You get back some generic JWT boilerplate. Wrong framework, wrong patterns. You end up rewriting 80% of it. Sound familiar? Now imagine the same prompt, exact same words. But this time, the AI has your CLAUDE.md file loaded with your tech stack. It's retrieved your team's authentication patterns from past PR. It knows your error handling conventions, and it can see your existing code structure. Same prompt, completely different output. Production ready code that actually matches how your team builds software. The difference isn't the prompt. The prompt was identical. The difference is the context. And that's the fundamental insight. We spent 2 years optimizing the words we type into AI. But the words were never the bottleneck. The information environment around those words, that's what determines output quality. So, what is context engineering? Let me give you the clearest definition. Anthropic defines it like this. Building with language models is becoming less about finding the right words for your prompts and more about answering the question, what configuration of context is most likely to generate the model's desired behavior? Look at this diagram. The prompt, the thing we've been obsessing over, is just one small piece of the total context. Context includes your system prompt, your conversation history, retrieved data from RAG or search, tools the model can use, memory from past sessions, and the current state of whatever task the AI is working on. Prompt engineering optimizes that little circle in the center. Context engineering optimizes everything around it. And here's the key quote from Andrei Karpathy that kicked off this whole movement. The hottest new programming language is English. Well, in 2026, the update to that is the hottest new engineering discipline isn't writing English better, it's curating what the model sees. Birgitta Böckler from ThoughtWorks put it perfectly. Context engineering is curating what the model sees so that you get a better result. Let's put these two side by side so the difference is crystal clear. Prompt engineering crafts the instruction. Context engineering designs the entire information environment that instruction lives in. Prompt engineering optimizes a single interaction, one prompt, one response. Context engineering optimizes all interactions. Every session, every agent, every team member gets the same high quality context. And this is a big one. Prompt engineering is manual and per session. Every time you start a new chat, you re explain everything. Context engineering is systematic and persistent. CLAUDE.md persists across sessions. RAG pipelines run automatically. Memory systems accumulate learnings. The question shifts from how do I word this to what should the model see? That's a fundamentally different engineering problem. And crucially, prompt engineering is an individual skill. Context engineering is team level infrastructure. When one person writes a great Claude MD, every developer on the team benefits. Every AI session benefits. It compounds. So, how do you actually do context engineering? There are four pillars, four operations you perform on information before it reaches the model. Pillar one, write. You take raw information, your code base, your docs, your conventions, and you structure it into text the model can reason over. This is Claude MD. This is your system prompts. This is your rule files. Pillar 2, select. You retrieve only what's relevant using semantic search, not keyword dump. The research is very clear on this. A JetBrains study showed that simple observation masking, just hiding irrelevant information, improved accuracy by 2.6% while cutting costs by 52%. Less noise, better results. Pillar 3, compress. summarize, and distill. And this is counterintuitive. Giving the model more context often makes it worse. The Stanford ACE paper proved this. The needle in a haystack problem is real. More tokens doesn't mean more intelligence, it means more confusion. Pillar 4, isolate. Prevent cross contamination between different tasks and agents. Each agent should see only what it needs for its specific job. This maps directly to the work tree isolation we talked about in the loop engineering video. Write, select, compress, isolate. These four operations are the foundation of everything. Let's make this concrete. The single most important context engineering artifact you can create today is a CLAUDE.md file. Look at this example. It's a simple markdown file sitting in the root of your project. It tells the AI, here's my stack. React 19 with TypeScript, Tailwind CSS, no styled components. Here are my rules. All errors use the app error class, use Vitess not jest, always run lint before commit. Here are my patterns. Use server actions, not API routes. Now, every single time Claude Code opens your project, it reads this file first, before you type anything, before you write any prompt. The context is already loaded, and here's what that gives you. The AI knows your stack, so it won't suggest Next.js when you're using Remix. It follows your rules, so every error handling block uses app error. It uses your patterns consistently. It persists across sessions. You close your terminal, come back tomorrow, the context is still there, and it's shared with your entire team. Anyone who clones the repo gets the same context. This is context engineering in its simplest, most powerful form. One file, massive impact. Here's an insight from Anthropic that I think is genuinely underappreciated. Tools are context. When you give an AI agent a set of tools, those tool definitions go into the context window. The model reads them, reasons about them, and decides which ones to call. This means poorly designed tools pollute the context just like bad prompts do. Anthropic's blog post explicitly calls out bloated tool sets as the number one failure mode they see in production. Look at the left side, 6 functions that all kind of do the same thing. Get user data, fetch user info, retrieve user profile, load user details. If you can't tell the difference, the model definitely can't. The right side is clean. 3 tools, each with a clear, distinct purpose. Get user, search records, update record. No ambiguity, no overlap. Anthropic puts it perfectly. If a human engineer can't definitively say which tool should be used, the model won't be able to either. This is context engineering applied to tools. Fewer, sharper, more distinct tools with clear descriptions. It's like the API design principles we've always known, but now they directly impact AI performance. Now, here's the part that surprises everyone. More context makes AI worse, not better. This isn't my opinion. This is backed by serious research. A JetBrains study presented at a NeurIPS workshop found that simple observation masking, literally just hiding irrelevant information from the model, improved accuracy by 2.6% while cutting costs by 52%. Read that again. Hiding information made the AI smarter and cheaper. The Stanford ACE paper took it further. They showed that structured incremental context updates reduced drift and latency by up to 86% compared to dumping everything into the context window at once. And this maps to something you've probably experienced intuitively. When you dump your entire code base into a prompt, the AI gets confused. It hallucinates. It misses the important parts. That's the needle in a haystack problem. The more hay you add, the harder it is to find the needle. The lesson is clear. Context engineering isn't about giving the model more. It's about giving the model less, but the right less. Now, let me give you the architecture, the mental model for how context actually flows to the AI. Think of it as a 3-layer stack. At the bottom, the persistent layer. This is always present. Read every single session, your CLAUDE.md file, your system prompts, your team's coding rules, your .cursor rules file. This is the bedrock. It changes rarely but impacts everything. In the middle, the session layer. This is retrieved at runtime and changes per task. RAG results pulled from your docs, conversation history from the current session, file contents the agent reads, git diff. This is dynamic but scoped to the current work. At the top, the transient layer. This is temporary. It exists for one operation and then it's gone. Tool outputs, API responses, test results, lint errors. The agent uses these in the moment and they don't persist. The key insight is that the bottom layer is the most stable and the top is the most volatile. Good context engineering means getting the persistent layer right first, because it's the foundation everything else builds on. If your CLAUDE.md is wrong, no amount of clever RAG or tool design will fix it. Start from the bottom, get the foundation right, then work your way up. All right, let's make this actionable. 4 steps you can take right now. Step 1, write your CLAUDE.md. If you're using Claude Code, run /init and it'll generate a starter file for you. But don't stop there. The auto-generated one is generic. Make it yours. Add your team's specific conventions, your error handling patterns, your architectural decisions. This is the highest leverage thing you can do today. Step 2. Trim your tool set. If you're building agents with tools, audit every single tool definition. Remove duplicates. Make names self-explanatory. Write clear descriptions. Remember, if a human engineer can't tell which tool to use, the model can't either. Step 3. Scope your context aggressively. Don't dump your entire code base into the context window. Use at file references to include only what's needed. Give the model what it needs for this specific task, nothing more. Less is more. We saw the data. Step 4. Measure and iterate. Track output quality before and after you make context changes. This isn't vibes. Context engineering is measurable. Compare outputs, track acceptance rates, log which context configurations produce the best results. These 4 steps will fundamentally change the quality of AI output in your projects. So let's bring it all together. We've spent 2 years getting better at prompting, and that skill isn't going away. Prompts still matter, but they're just one small piece of a much bigger picture. The shift is clear. The teams and developers who are getting the best results from AI in 2026 aren't the ones writing the cleverest prompts. They're the ones engineering the best context. A great CLAUDE.md file, clean, lean tool definitions, scoped relevant retrieval, structured context stacks. These are the things that separate AI code that ships from AI code you rewrite. Better context, not better prompts. That's the message. If this helped you understand context engineering, do me a favor. Hit that subscribe button. I'm breaking down the latest in AI and development every single week, and I promise you the next video is going to be just as good. Drop a comment below. Tell me, what's the first thing you're going to add to your CLAUDE.md? See you in the next one.